Section 5.6 is about applications and proportions. And there's three objectives. One is to solve work problems and certain basic problems using rational equations, a topic we just covered in section 5.5. And then also we solve applied problems involving proportions. That may be a new concept for some of you. And then we're going to solve some motion problems using rational equations. The first thing we're going to look at has to do with work. So here the city wants to develop playground sets, and they're within walking distance of every child in the city. So the city provides the plans and assigns the construction to volunteer groups. So here's the essence of it. Volunteer group A can build a playground in 20 hours. Volunteer group B can build the same playground in 25 hours. How long will it take for them working together to build the playground? So here we talk about rates, and what it basically says is that group A works at a rate of 1/20th of an hour for the project, and group B is 1/25th of the project per hour. So, and here's the work principle explained this way, and that is, suppose that A is the time it takes group A to do the job, and B is the time it takes group B to do the job, or B, and T is the time it takes them to do the job working together. Then T divided by A plus T divided by B equals 1. Okay, so we're talking about rates here. So again, for group A, they can do it at a rate of 1/20th of the job per hour, and the group B 1/25th of the job per hour. So applying this work principle to this current problem, we are now looking at the following rational equation. T is the time we want to find out about, divided by 20, plus T divided by 25, that's for group B, equals 1. And the 1 stands for one job or one playground that they build together. So we know how to solve these type of rational equations. We multiply it by the LCM, which is 100 in this case. So the LCM equals 100. So then 100 times T divided by 20 plus 100 times T divided by 25 equals 100 times 1. Again, we multiply each term of this rational equation by 100, our LCM. So then we can cancel the 20 against the 100, which gives us a 5T. And the 25 against the 100 gives us a 4, or a 4T. And that equals 100. And 4T plus 5T is 9T. Equals 100. So we divide by 9 on both sides. So T equals 11 and 1/9 of an hour. So that's obviously the mathematically correct statement, but 1/9 of an hour is not very helpful. But when you think about it, 1 hour has 3,600 seconds, so 3,600 divided by 9 would be 400 seconds, and 400 seconds would be 11 hours, and 400 seconds would be 6 minutes and 40 seconds. So that's the mathematically correct expression, and this is the one that is more helpful, because we typically don't think in 1/9 of an hour. Again, at best it's 400 seconds, and 400 seconds would be 6 minutes and 40 seconds. So that's how we can solve work problems. So the next example talks about filling a water tank. 2 pipes carry water to the same tank. Pipe A, working alone, can fill the tank 3 times as fast as pipe B. Together, the pipes can fill the tank in 24 hours. Find the time that it will take each pipe to fill the tank alone. So we can start with the basic equation that we had a moment ago. T divided by A plus T divided by B equals 1. Except in this example we know what T is. So T is equal to 24 hours. So we have 24 divided by A plus 24 divided by B equals 1. 1 tank filled. However, we are told that A can fill the tank 3 times as fast as B. So A equals 3B. Or rather, yeah, B equals 3A rather. So with this additional information, we can now rewrite the equation as 24 divided by A plus 24 divided by 3A equals 1. So now we have a rational equation, and our LCM is obviously 3A. So LCM is 3A. So we multiply each expression by 3A. So we have 3A times 24 divided by 2A. So we multiply the first term by 3A plus 3A times the second term, 3A times 24 divided by 3A equals 1 times 3A. So as we cancel the denominators, that's just A, that's not 2A. So the A's cancel, and 3 times 24 is 72. Here the 3A's cancel, and we have 24 equals 3A, or writing it the other way around, 3A equals 72 plus 24 would be 96, or A would be equal to 32 hours. So A can fill the tank alone in 32 hours, and since B is 3 times A, then B can fill the tank in 3 times 32 hours, or 96 hours. So here's a new concept for you: applications involving proportions. A proportion really says that two ratios are equal. A divided by B is equal to C divided by B. Or A is to B as C is to D. And that's called a proportion. The numbers named in a two proportion are said to be proportional to each other. In other words, A to B is proportional to C to D, as C is to D. So a very useful concept in mathematics, as you will see. A typical way to solve a proportion is when we have this equation A to B as C is to D, is we cross multiply. In other words, A times D is equal to B times C. And since we typically know 3 out of these 4 numbers, we can solve for the unknown, for the variable that we are looking for. In the next example, the guided solution, we'll see how that works. Calories burned, and that's about Mia, who weighs 120 pounds, will burn 110 calories in 20 minutes during an aerobics class. How many calories will she burn in 35 minutes? So let C be the number of calories burned in 35 minutes. So now we have the proportion of 20 to 110 calories would be equal to 35 minutes to C calories. So we cross multiply. 20 times C equals 110 times 35. So 20C equals 3,850, and then we divide 3,850 by 20. So then C would equal 192.5 calories. In 35 minutes. For the next example, estimating wild horse population. To estimate the number of wild horses in Nevada, a rancher catches 560 wild horses, tags them, and releases them. Later, 133 horses are caught, and it is found that 4 of them are tagged. Estimate how many wild horses there are in Nevada. So let's just say that H would be the number of wild horses in Nevada. So H, the number of wild horses in Nevada. So you set up the proportion as follows. So H, the number of horses, and out of which now 560 are tagged. Okay, so these are the ones that are tagged. And that equals, out of 133 horses that they caught later on, 4 of them are tagged, so divided by 4. So you have to be careful to keep the numbers in the numerator and denominator straight, that these are the number of horses and these are the number of horses that are tagged. This is the total number of horses, that's the number of horses that are tagged. So the rest is pretty straightforward. We cross multiply. So 4H equals 560 times 130. Which is 72,800. Now we divide both sides by 4, and so H would be about 18,620 wild horses. That, of course, is an estimate. Next, we'll be talking about some basic motion problems. And the basic motion formulas are as follows. D equals R times T. In other words, distance equals rate times time. And we can solve the equation for R, for the rate. It would be distance divided by time. Or we can solve the equation for time, which would be distance divided by rate. So let's look at the following example. Four-wheeler travel. Olivia's four-wheeler travels 8 kilometers faster than Emma's four-wheeler, apparently. Olivia traveled 69 kilometers in the same time it takes Emma to travel 45 kilometers. Find the speed of each person's four-wheeler. So let's say that E would be the speed of Emma's four-wheeler, speed of Emma's four-wheeler. And let's say that O would be Olivia, the speed of Olivia's four-wheeler, speed of Olivia's four-wheeler. So we know that T equals distance divided by R, and we are told it takes them the same time. So the distance that Olivia traveled, 69 kilometers, divided by her rate, that would be divided by, O is not a real good, better make it a G, otherwise it looks like a 0, is equal to the same distance that Emma travels in her four-wheeler. Now we are told that Olivia's four-wheeler travels 8 kilometers per hour faster than Emma's. So, in other words, Emma's speed is equal to Olivia's speed, G minus 8. It's 8 kilometers slower, it's another way of saying it. So then that becomes 45 divided by G minus 8. So in other words, we have the proportion, so 69 kilometers divided by the speed of Olivia's four-wheeler is equal to 45 kilometers divided by Emma's four-wheeler. And since Emma's four-wheeler is 8 kilometers an hour slower than Olivia's, E equals G minus 8. So we have the proportion 69 to G equals 45 to G minus 8. So we cross multiply. So we get 69G minus 552, which is 69 times minus 8, equals G times 45, or 45G. So now we subtract 45G on both sides and add 552. So then 24G So here we cross multiplied, 69 times G is 69G, and 69 times minus 8 is minus 552, and G times 45 is 45G. If we subtract 45G on both sides, it gives us 24G on one side and 552 on the other side. We divide by 24 on both sides, so that means that G is equal to 23 kilometers per hour. 23 kilometers per hour. And so since E is G minus 8, that means Emma's four-wheeler travels at a rate of 23 minus 8, or 15 kilometers per hour. So the faster one goes 23 kilometers an hour, and the slower one goes 15 kilometers per hour. The last example is about riverboat speed, and here it says the riverboat cruise line has a boat that can travel 76 miles downstream in the same time that it takes to travel 52 miles upstream. The speed of the current in the river is 1.5 miles per hour. Find the speed of the boat in still water. So let's say we go downstream and 76 miles. And then upstream would be in the same time for 52 miles. So if x is the speed of the boat in still water, then the speed of the boat going downstream would be x plus 1.5 is the speed of the boat going downstream, speed going downstream. And x minus 1.5 is the speed going upstream. And remember that the time is the same, so d equals d divided by r. So we have two distances and two rates, and we know they're the same. So we can write the following equations. We can write that 76 miles going downstream, 76, that's the distance, and the speed, the rate of travel going downstream is x plus 1.5, and that's equal to the same time as the speed going upstream, which is 52 miles. So the distance is 52 miles going upstream in the problem statement, 52 miles upstream. And the rate at which the boat is going is equal to 1.5, x minus 1.5, x minus 1.5. So when we cross multiply, we multiply 76 times x minus 1.5. That's equal to 52 times x plus 1.5. That's 76x minus 114, 76 times 1.5. And on the right side we have 52x plus 52 times 1.5 is 78. We subtract 52 on x on both sides, so we have 24x. And we add 114 to both sides. That gives us 192. Now we divide both sides by 24, so x equals 8 miles per hour. So that is the speed of the boat in still water. And this is a conclusion of section 5.6. Sorry about that. This concludes section 5.6.